Here are your notes for the complex plane, and then we will also discuss Euler's formula. So this is just to expose you to complex numbers. We're not going to get really into depth with them. That will happen in your future courses. But you have talked about complex numbers some point before you came into 112. A complex number is in the form of a plus bi, where a is the real part and b is the imaginary part. And if you can remember, back in the day you learned it, the definition of I, I'm going to put it right here, is the square root of -1. So if you were to square both of those, I squared is equal to -1. So remember, you talked about this in some previous math course where, you'll do all this work and you end up taking a square root of a negative number, which is not a real number. There's no way we can figure that out. So it takes on this name as an imaginary number, which kind of seems like, why are we talking about it if it's imaginary? But it really does have really important concepts behind it and going on in your math courses and engineering especially. So just to give us some basic background with complex numbers, example 1, for complex numbers, I'm going to call it z equals 1 minus 3i, and w equals -3 plus 2i. We're just going to show you how you can combine complex numbers just like we would real numbers. So if I'm going to add these two complex numbers, it would be 1 minus 3i plus -3 plus 2i. Well, we can only combine like terms, so I can combine the real parts, so I get -2, and I can combine the imaginary parts, so I get -i. And that is all you can do, right? We can't combine unlike terms. So what that's telling me is my real part is -2 and my imaginary is -1. I can also subtract them. So in B, I have 1 minus 3i minus this entire complex number. So I'm going to use parentheses so I don't forget to take off that imaginary part. So if I distribute that negative, we end up getting plus 3 minus 2i. And then once again, you can combine the only like terms. So 1 plus 3 is 4. -3i minus 2i is -5i. And we could also multiply complex numbers. So I'm going to go ahead and set this up. 1 minus 3i in parentheses times -3 plus 2i. And so this brings us to good old FOIL. We have 1 times -3. Then we're going to do outer 1 times 2i. Let's make that I a little bit better. -3i times -3, so we get plus 9i. And then -3i times 2i, we get -6i squared. Okay, so we can combine like terms, and we have -3, I'm just going to leave it alone, but then I have plus 11i minus 6i squared. I'm going to run out of space, so I'm going to jump up here. Well, remember, I squared actually is a real number, so it becomes -1. So we have -3 plus 11i minus 6, but that I squared is a -1. And so that becomes a plus 6, so we end up getting 3 plus 11i. So don't forget that I squared becomes a real number. And that is because if I squared this and I squared this, it would get rid of that radical. Okay, so that takes care of those like basic operations with complex numbers. So the next piece we're going to talk about is how to plot this on a complex plane. So because complex numbers have two parts, we can use our rectangular coordinate system to plot complex numbers. We use the horizontal axes. This is known as our real axes. And we use the vertical to represent our imaginary. All right. So if I have A plus BI, you're going to go over the A part horizontally, and you're going to go up or down the imaginary part. So if I ask you an example 2 to plot these, I'm going to go ahead and give myself an axis. I'm going to label this as my real and this is my imaginary. Give yourself a scale. And you don't have to write I on your vertical axis because it's understood, since I labeled it imaginary, that it's imaginary. So for Z, I want to go over 1 because that's my real part, but then I'm going to go down 5. So this is, and give myself a different color. This is where Z will live. And so for W, I'm going to go over 3 to the left because it's -3 on my real part, and then up 2. And that is your W. So that's where your complex number would live. Okay, so that takes care of just basic operations with complex numbers. So again, just exposing this to you again, and then how to plot them.